Today we're going to look at lesson 3.1, but I want to walk you through something I've done now. I've kind of been showing you the last few days, but I'm going to show you right now a little bit more in detail. Starting now, if you want to use Google Classroom, you can. Everything's loaded up there. What you would do is you choose My Period or from all your classes. If you go to classwork, today is lesson 3.1. And so if you click on lesson 3.1 right there, this will pop up everything you need to do for the day. If I can get it to open. Okay, what's going on? Let me refresh this. Well, this is embarrassing. Okay, 3.1, there it is, finally. Once it opens up, if you click on this, this will just, it's a Google Doc giving you all the things that are required to do. So your attendance link, number one. Number two, I talk about different ways you can learn. Obviously, the number one, as I recommend, being in class live in person, but I'm not even there today, just being sick. So you're doing the second bullet point right now. You are attending live via Zoom. And also there's the digital resources. I noticed that YouTube playlist. We're going to use that today in a little bit down below that table. The thing that's required for you to do today, also for your attendance, so not only do you have to fill out this attendance link, DISD requires that you submit some type of assignment, so that number 3, the lesson exam, or the Bellringer's Guided Practice Released ACP questions, we're going to turn that in right there as well today. Your homework will be due next Thursday. So there's the view from Google Classroom. Again, that was 3.1. So I'm not sure why it wasn't opening right away. I first clicked it, but there, whoops, but there it is in chapter 3. You can also get to this from PowerSchool Learning. So this is 5th period. So when you sign into PowerSchool Learning, if you want to use that, it now looks a little bit different. I've updated it so that I can incorporate with Google Classroom. What you would do is you go over here to chapter 3. If you want to continue using PowerSchool Learning, and there's the same little document that I showed you for lesson 3.1. This one doesn't have the table for the Zoom links, but we're going to knock out the first 3 things today. Okay, so with that, let's go look at the bell ringer. So usually the first lesson of a new chapter, I do some review, and that is the case here. So number 1 is, this comes from lesson 1.6, so it's been a little while. This is from lesson 1.6, chapter 1. It said, if f of x equals 3x plus 2, g of x is 2x squared, and h of x is x minus 5, what is f of g of h? What was our technique of finding f of g of h? What did we do back in chapter 1?
Stack.
That's right, we're going to stack. And so you go in order that they want you to find. We're supposed to find f of g of h. So I'm going to write it in that order. So h is x minus 5, g is 2x squared, and f is 3x plus 2. And so from here, we then just substitute going up. So I take my x minus 5, and I substitute that in for h, or for the x. So h is getting shoved up into g. That's the idea here. And so I'm going to have to work this out on the side because I won't have room today. Working from home, I don't have the same tools I do at school. But that's basically what we have when we substitute. And so I'm going to work that out real quick. I'll FOIL it up here. So we have 2, and it's going to be times x minus 5 squared, which just means x minus 5 times x minus 5. I will FOIL first, and then I'll multiply the 2 through. You could do the 2 through the front parenthesis first if you would like, but I'm just going to multiply FOIL first. So I'll have 2 times x squared times negative 5, or minus 5x, another minus 5x, and then a plus 25. Whenever I combine my like terms and distribute the 2, this will simplify. Let's do a little mental math here. 2 times x squared is going to be 2x squared. That was right here. But I'm going to first incorporate this. What's minus 5x minus another 5x?
0.
Negative 10x.
Oh, there you go. Yep. With adding and subtracting, think of money. And so it's like I owe someone 5, I owe someone else 5. So I owe a total of 10. I multiply that times 2, I now owe 20. And then 2 times 25 is 50. So we just found out that all this is 2x squared minus 20x plus 50. And we take that, and we would substitute that up into this x. All right, we're going to be writing all over this front page here. So we'll have 3 times 2x squared minus 20x plus 50. That's an ugly parenthesis there. And we need to add 2 to this on the outside. So when we simplify all that out, I get 3 times 2x squared would be, let me write f of g of h. 3 times 2x squared is 6x squared. 3 times negative 20x is negative 60x. 3 times 3 times 50 is 150, and I'm going to add 2 more of that to get 152. So I just distributed this 3 through, but I had to add the 2 at the very end. So that's how I got that answer. We could check this if you wanted to on Desmos. And so the way to check that on Desmos is you would type in your 3 equations. Now you would need to name these. So I'd have to name it f of x, whoops, the x didn't go in, equals 3x minus 2, no, plus 2. And then you would type in g of x, which was 2x squared if I remember right. And you could type in h of x, which was x minus 5. Okay, you don't actually have to look at these 3 equations. What you're really going to look at is f parentheses g parentheses h of x. That right there is what the solution should look like. We got the solution to be, if I remember right, 6x squared minus 60x plus 152. No, 152. Okay, so either I made a mistake.
For f of x, you forgot the 3x.
There we go. Sweet. So did we do it correctly?
Yes.
Yeah, we did. The graphs match. Sweet. So that's number 1. Okay. Number 2, it's about, what does that little j negative 1 mean?
Inverse.
That's right. And so when we find an inverse here, what we're going to do is switch x and y. And so we could do this by graphing, which I'll show you there at the end. But the way you do this is you switch x and y and solve from there. So instead of having j of x basically means y, x equals 4y squared minus 1. And we'll solve that for y. So this is right here, that x equals, that is the equation. It's just not in standard form. Normally we solve it for y. That right there, if we type that into Desmos, we'll graph because that is an equation and you'll know what the inverse looks like. But to do it, to solve for y, how do I get rid of, I'm going to solve this for y. So how do I get rid of a minus 1?
Plus 1.
Add 1.
We add 1 to each side. And so we have x plus 1 equals 4y squared. How do I get rid of multiplying by 4?
Divide by 4.
Okay, now I need to divide everything by 4. So that goes away. Now I have x plus 1 over 4 equals y squared. Last step, how do you get rid of a square?
Square root it.
Square root. Now, anytime you add a square root that's not originally there,
Is
Plus or minus.
plus or minus.
we need a plus or minus. So here's what that means. We get the equation y equals plus or minus the square root of x plus 1 over 4. Now this will be good to look at by graph because it'll kind of remind a lot of students anyways. Oh, by the way, if you wanted to, you could simplify this and put it over 2 because the square root of 4 is 2, and then put the square root only on the top if you wanted to write it that way. You don't have to, but I did want to show you that you could simplify part of that fraction without simplifying the whole thing. You can treat square roots like that. So on the left here, the square root's over the whole thing. On the right, I took the square root of 4 and made it a 2 in the denominator. You can do that if you'd like. But this is good to see why we need that plus or minus. So over here, let me turn that one off. That was number 1. Number 2 here, we have x equals 4y squared. What was the number that was with it? Minus 1, I think. Okay, I'm going to just say it was minus 1. Why we need to have the plus or minus is because if you don't, you only get half of that parabola. We're only going to get half of that sideways parabola if I type it in like this. X, put 4 on the bottom, x plus 1 over 4. You see how it's that green is only half that parabola? A square root graph is only half of a parabola. And since it was supposed to be a full parabola, up here, a squared is a full parabola, you need the positive and you need the negative. And so that's why this would be plus or minus that square root. There we go. It matches. So we did it correctly. I can change this to green so you can see the whole thing now. And green as it compares to the blue. So it matches. Okay, so that was number 2. Let's talk about number 3. Algebraically, how can we find domain? Do you remember the 2 rules for domain? What are you not allowed to do in mathematics?
You're not allowed to divide by 0.
That's right. So that's how we'd set it up. If you add a division, you set up the denominator is not equal to 0. That's rule number 1. Rule number 2 is that a square root of x has got to be greater than or equal to 0. You can't have a negative square root. So those are our 2 domain rules. I just wrote them by symbols this time instead of using English. So to solve this, basically what we're going to do is set the denominator cannot equal 0 to get our domain. And from there, I need a factor. What type of factoring can we do in the denominator? Do we do X method when it's 2 terms?
You can factor out x.
Ah, there you go. We can factor out X. That's great. So this is called GCF, greatest common factor. And so we would factor out an X, and we're left with 2x minus 3. All that cannot equal 0. And so there's going to be 2 breaks in this domain. When you separate this is using Algebra 2's, if you remember the zero product property, that anytime you're multiplying, which on the left side here, let me switch colors, on the left side of the equation, we are multiplying. The only way you can multiply and have a product of 0 is if one of those factors is 0. So you solve each one individually. And since this one is a not equals to, I'll use that symbol. So x could not equal 0, and 2x minus 3 cannot equal 0. Since inside lies, when we solve the right side, we're going to end up with x cannot equal a positive 3 divided by 2. Since it looks like multiplying by 2 and subtracting 3, it becomes positive 3 dividing by 2. And so those are our 2 values. You could leave your answer in this form, Or if you were writing it in interval notation, it would mean you can go from negative infinity all the way to 0 with a parenthesis, because we're not equal to that 0, so a parenthesis means it doesn't actually equal that number. And then go from 0 to 3 halves, parenthesis, and then 3 halves to infinity, like that. Hang on, my appraiser is calling. Let me pause. Okay, any questions on number 3 here?
No, sir.
No.
All right, let's go over. Hopefully y'all have the equation written down so you can tell me. And so number 3 here. Did they call it k of x? Is that what they called it? Not that it really matters what they called it, but I'll label it the same. K of x equals, and it was a big time fraction. And all I remember was on the new denominator. Well, let me click the denominator yet. Oh, there it goes. It was 2x squared minus 3x. I remember that. 3, come on. All right, what was the numerator? Do y'all remember?
2x squared plus 5x minus 12.
Plus 12 or minus 12, did you say?
Minus 12.
Okay.
It's plus x plus 5x.
Plus 5x. Like that?
Yes.
All right. Okay, so on this problem, when you look at the domain here, it does look like it's breaking at 0. Let me see if it'll, no, it won't let me write on this app. Okay, so it does, we can tell that it's breaking at 0, and if you also hit the edit list and hit the convert to table button, you can see at 0, it's undefined. That does mean it's a break. On whenever the graph says undefined, it doesn't tell you what type of break it is, but it does mean it breaks there. As we can see, it's an infinite discontinuity or a vertical asymptote because it's breaking and the graph is vertically going to infinities, so it's a vertical asymptote, also called an infinite discontinuity. But we had a second value, and that was 3 halves. And you notice if I put in 3 halves, it says undefined. Since I can't see 3 halves, that's 1.5, that means it must be a removable. And so if I don't know if I'm going to be able to do this with my finger here. Well, maybe I had it for a second. I'm trying to get it right there. You see how that's an open circle? That's a removable discontinuity, also called a hole. And so that one we found algebraically, and you could see it on the table, but you don't see it on the graph. That's what makes it a hole. So anyways, those would be the 2 answers there. That's where the domain breaks. Oh, I didn't realize that is number 4. So we can say infinite discontinuity at x equals 0, sorry. And it was a removable or a hole at x equals 3 halves. That's an ugly at sign. I'm just trying to say at. Again, how you would get that algebraically is if the equation cancels. So if you factor the denominator, or excuse me, the numerator, they would cancel, and that's how you get that. So I'll finish up this right here, and then I'll be done with this bell ringer. If you factored out the numerator and said that 8 times c, which is negative 24, over 5, the factors are going to be 8 and 3. 8 times 3 is 24, and I can get a 5 if I say 8 minus 3. And I check it, 8 times negative 3 is negative 24. It's great. So I split this a power, and so it'll be 2x plus 8 and 2x minus 3. Because my a is greater than 0, or greater than 1 rather, I need to divide by that value of a, and it looks like it's going to be the front parenthesis that can be divided by 2, not the back. And so that means this numerator here could be rewritten as x plus 4 over 2x minus 3. If you remembered earlier when we factored the denominator, we had x times 2x minus 3. So algebraically, the reason why the 3 halves was a removable is because you can remove it from your equation there. but the factor of x could not be removed. It's there forever. Since it's there forever, we call it an infinite discontinuity. So there's the algebra behind the graphing. Questions over that?
No, sir.
All right. So I've hung in about as long as I can. I'm kind of at wit's end here. Let me